The next topic is the magnetically coupled circuit in conductively coupled circuit form. Okay, so till now I haven't seen any questions in university, but the solution is similar to what we discussed in magnetically coupled circuit, but here there will be a conductive coupling also. So in the magnetically coupled circuit there will be no connection between two coils, but here there will be connection between two coils. Okay, just to learn how do we solve it, that's all. Okay, there will be no complication in this, just the same method, same dot convention we'll be using for solving the problem. There will be no difference, just go through the method. Okay, suppose if it is asked, you can directly write the solution for it. Okay. The question is calculate mesh current in the circuit of figure shown below. Okay, here this is a circuit. In the previous example and all, there will be no connection between two coils, conductively coupled, magnetically coupled coil. Here there is a connection also. There is a conductively coupled as well as magnetically coupled. Okay, so that is the specialty of this particular circuit. Okay, but the way of solving is same, but we need to be careful, okay, while dealing with this, because there is a connection. Okay, see here loop 1 have current I1 and loop 2 have current I2. So if I apply KVL at loop 1, so what I will get? I will get minus 100 angle 0, because I1 is entering negative, leaving positive. So minus 100 angle 0 plus 4 I1 minus 3J, so minus 3J I1. Okay, so I have written this and this. So now we got a coil. Okay, now we got a coil. So through that there will be a current flow. Which current will flow, whether I1 or I2 or both? So we know that if I consider the downward direction, what current will flow? I1 minus I2. So this we can identify by simply applying KCL at this node. Simply applying KCL at this node, because here we have current I1, here we have current I2, and in this direction let us assume the current is I. So we can write I1, I is entering, so plus I1, I2 is leaving and I is also leaving. So I will be equal to I1 minus I2. Okay, the I1 and minus I2 is the current flowing from top to bottom in the direction, in the clockwise direction. So the self-induced voltage will be plus J6 I1 minus I2. There will be one more voltage, we call it as mutually induced voltage. There is one more voltage here. So that is due to the current flowing through J8. Okay, so the current I2 is flowing through J8. Okay, it is entering the undotted terminal. So the generated voltage positive will be at undotted, negative will be at the dotted terminal. Okay, and then induced voltage will be, so mutual inductance J2 multiplied by current I2. Okay, so if I compare the direction of I1 is entering negative and leaving positive of mutual induced voltage. So it does not obey passive sign convention. So minus J2 I2 equal to 0. Let's compare it. Minus 100 plus 4 minus J3 I1 plus J6 I1 minus I2 minus J2 I2. Okay, it is correct. This is the equation we got. So I am simply rearranging those equations to get this. I just simply rearranged it. Okay, so I don't want to do the mathematical part, that you can do it on your own. Okay, the minus 100 angle 0 is taken to the right hand side, will become plus 100 angle 0. So remaining calculation you can do. Okay, so this is the equation we got. Okay, next we will go to the second loop. It is a bit complicated. Okay, so listen carefully. Okay, listen carefully. Okay, there are two magnetically coupled coil in this loop. In the previous loop there was only one. Okay, in this loop we have two. If I have a magnetically coupled coil, there will be two voltages. One is self-induced voltage and another one is mutually induced voltage. Okay, across J8 there will be two voltages. Across J6 also there will be two voltages, self-induced and mutually induced. So both the voltages should be addressed while writing the equation. Okay, so how many voltages will be there? There will be self-induced voltage and mutually induced voltage across J8. There will be self-induced and mutually induced voltage across J6. So 1, 2, 3, 4, and then voltage across 5 ohm. Okay, 1, 2, 3, 4, 5. So there are, you can expect 5 different voltages here. You can expect 5 different voltages. Okay. So let us write now. I'll clear all this. So be careful and look at what I am writing. Okay. So I can start from here. Okay, I can write I2 is the current flowing here. So I can start with 5I2. I am applying KVL at loop 2 or mesh 2. Okay, so 5I2. Okay, next case is while coming here. Okay, the current is from bottom to top. Let us assume this direction. So I need to know what current is flowing through this. Okay, not only I2, I1 also will flow in the opposite direction. So I need to consider both the currents because it is conductively coupled. In previous case there was no connection between two coils. Okay, so we consider either I1 or I2. But in this case, one side of coil I1 is flowing, other side of coil I2 is flowing. So I am supposed to consider both the currents. Okay, so I need to know which current is flowing from bottom to top. So I'll just consider this node B. Here I2 is flowing in this direction, I1 is flowing in this direction. I want to know the current I flowing in the upward direction. So apply KCL simply. I2 is entering, I1 is leaving, and I is also leaving. So I will be equal to I2 minus I1. So I2 minus I1 is the current flowing through this J6. Okay. So I2 minus I1 is the current flowing through this J6. So I'll write I2 minus I1. Okay, so I'll be writing the self-induced voltage. So plus J6 I2 minus I1. Okay, plus J6 I2 minus I1. Okay, and there will be a mutually induced voltage due to the current I2 flowing through this J8. So because it is a coil, if the current is flowing through the coil, it is going to induce a mutual voltage, okay, in the nearby coil. Okay, so through J8 there is a current I2. Okay, in this direction current I2 is flowing through the coil. So it will be generating the voltage across J6 in this direction. It is entering undotted. So generated voltage positive will be at the undotted terminal and negative will be at the dotted terminal. So plus minus. Okay. So now consider the current direction of I2. I2 is entering positive, leaving negative. It is obeying the passive sign convention. So the voltage, generated voltage can be written as plus J2 times I2. Because the generated voltage across this J6, it depends on I2 current entering through J8. Okay, so I need to consider the mutual inductance J2 multiplied by the current flowing through it. So J2 I2. So the plus J2 I2 is written here because I2 is entering positive and leaving negative of the induced voltage. So I'll clear all this so that we can avoid confusion. Okay, so we have mutual induced voltage plus minus J2 I2. Okay, so now there is a current I2 minus I1 flowing in this. Okay, so as we discussed earlier. Now due to the current I2 minus I1 flowing through J6, there is a mutually induced voltage across this J8. Okay, across the J8 there will be mutually induced voltage. So see here the I2 minus I1 is entering undotted. So generated voltage positive will be here and negative will be here. Generated voltage positive will be here and negative will be here. And what will be the generated voltage? J2 times I2 minus I1. Why it is I2 minus I1? Because I2 minus I1 is the current flowing through the coil, J6 coil, okay, which is inducing the mutual voltage across J8, So it is J2 I2 minus I1. Okay, J2 I2 minus I1. Okay, now compare the direction of I2. I2 is entering positive and leaving negative. So it is obeying the passive sign convention. So we can write plus J2 I2 minus I1. Okay, I'll write this 5 I2 plus J6 I2 minus I1. Okay, plus J2 I2, and then I have written the mutual induced voltage J2 I2 minus I1, and there is a self-induced voltage across this J8. Okay, that is due to the current I2. Okay, so we can write plus J8 I2 equal to 0. Okay, so this is the equation. So here I have written minus J2 I1 minus I2. Okay, or J2 I2 minus I1, both are correct. You can use any one. So how this minus J2 I1 minus I2 will come? So instead of considering this bottom to top direction, if you consider the top to bottom direction, okay, top to bottom direction, what is the current here? I1. What is the current here? I2. So let us take this as I0. Okay, so I'll just give the different name, which is the current flowing from top to bottom. So if I apply KCL here, I'll get I1 minus I2 minus I0 equal to 0. So I0 is equal to I1 minus I2. So that will be the current. Okay, I0 is I1 minus I2, which is entering the dot. Okay, which is entering the dot. So if it is entering the dot, the generator voltage positive will be here and negative will be here. Okay, and then the generator voltage will be same, J2 into I1 minus I2. That will be different, I1 minus I2. The current direction will change. Okay, so J2 into I1 minus I2. Okay, because I consider the direction from top to bottom. Okay, top to bottom. So if you see the current direction I2 and the polarity generated, it is not obeying the passive sign convention. So we got minus sign here, minus J2 times I1 minus I2. So both are correct. You can follow any one. So whichever is convenient, you can use it. So we can rearrange it to get this equation number 2. So kindly go through. So pause the video and do the mathematical calculation to get the equation number 2. Okay. So I got equation 1 and equation 2. Now I am going to solve this using Cramer's rule. Okay, now I need to represent in matrix form. So 4 plus J3 minus J8, okay, multiplied by I1 and I2. 4 plus J3 minus J8 multiplied by I1 and I2. And second equation, it's minus J8, 5 plus J18 I1 I2 equal to right hand side values 100 angle 0 0. How do you calculate del? So del can be calculated by taking the determinant of this 4 plus J3 minus J8 5 plus J18. Okay, so by taking the determinant of this, we'll get 30 plus 87J. 30 plus 87J. Okay, next del 1. Okay, I hope you already know the procedure. So this 2 to be multiplied minus this 2 to be multiplied. Okay, that is a procedure for calculating the determinant. Okay, next del 1. So this column will be replaced by the right hand side value. So 100 angle 0 0. And this will be taken as it is. This will be taken as it is. Okay, minus J8, 5 plus J18. So in this case, 100 angle 0 will be multiplied with 5 plus J18 minus 0. Okay, so we will be getting this value 500 plus 1800J. So I1 will be calculated by I1 equal to del 1 by delta. Del 1 by delta. So del 1 is 500 plus 1800J by 30 plus 87J. We'll be getting this 20.26 plus 1.2398J. Okay, in polar form, I1 equal to 20.3 angle 3.5 degree ampere. So next del 2. For del 2, this will be written as it is. The first column will be written as it is. The second column will be replaced with the right hand side value for the del 2. So again calculate the determinant. I will get 800J. So I2 will be equal to del 2 by delta. So 800J by 30 plus 87J will be 8.2182 plus 2.8338J. Okay, if I convert it into polar form, I will be getting I2 equal to 8.693 angle 90 degree amperes. Okay, thank you.